determine the equation of the straight line that's shown here. And when I say here, it's the diagram to your left-hand side. So let's break down the question. So starting off, we're asked to find the equation. So obviously what we need to be thinking is, well, what's the general equation for a straight line? So remember, it's y equals mx plus c. So if we break this down again into its elements, we know that c here is our y-intercept. We know m here is our gradient. So looking at the graph, let's break it down and do some analysis. So first up, we can see that there are 2 points of intersection. The first one occurring at the x-intercept, so that's just here, at 2, 0. And I'm just going to label here, that's our x-intercept. When you're starting out, it's a really good idea, where possible, to annotate your diagrams or put little labels around, just to sort of build up your confidence and your understanding and knowledge of the unit. So returning back to the question, so our y-intercept here, and I've just covered it, occurs at 0, 6, so when y is equal to 6. So that is our y-intercept. Another feature that we can see just by looking at this particular diagram is that our graph is, the gradient's actually negative, right? So this becomes really important when we're working out the gradient itself, like what the number is, because you need to realize that there's a negative now involved. The graph is sloping in a downward direction as opposed to going in a positive direction. So what do we know? Oops, sorry. So I like to write this down, at least when I was starting anyway. So we know the gradient is negative. And we actually also have 2 points of coordinates. So we have 2, 0 and 0, 6. So what we can do is we can actually use the gradient to find our coordinates to find our gradient. So we have the 2 coordinates here. So let's say that x1 and y1 is 2, 0 and x2 and y2 is 0, 6. So step 1, let's find our gradient. So using my personal preference method, so y2 minus y1 all on x2 minus x1 equals m. So m equals 6 minus 0 all on 0 minus 2. Remember, we're aiming for a negative gradient, so I'm going to get 6 on negative 2, so m is equal to negative 3. So this matches what we know. Looking at the graph, we know that the graph has a negative gradient, and we've just proven that it is. So as I work elements of the equation out, I actually like to substitute them in, so I've got like a progressive piece going through each time, and it sort of helps me build up to the final answer. So substituting m equals negative 3 into the equation, we're going to have y equals negative 3x plus c. So looking at the diagram, we already know that our y-intercept is 0, 6, or occurring when y is equal to 6. So realistically, we know that the answer will be y equals negative 3x plus c. Plus 6. So let's prove that though using algebra. So let's let's substitute a coordinate. So finding the y-intercept. So let's substitute in the coordinate 2, 0. So if I do 0 equals negative 3 times 2 plus c, I'm going to get 0 equals negative 6 plus c. What happens now is I'm going to move that negative 6 over, so that becomes 0 plus 6 equals c, so c is equal to 6. And again, this proves that the graph that we've been given cuts through the y-axis when y is equal to 6. Again, we've just confirmed this by using algebra. So the final piece of my puzzle will be actually writing the equation, which will be just write final answer. Y equals negative 3x plus 6. Therefore, we've just now found the equation to the straight line that we've been shown. So remember, if you're given the graph and you can read the y-intercept very clearly, by all means substitute it in. But again, using algebra, we can actually also find the y-intercept. The gradient you could have found using the rise over run method as well, or another gradient equation, which is just rearrangement of the formula that I've used here. But again, regardless of which method you choose to use, you will always arrive at the same final answer.